For residential applications, conduit should be buried at least 12 inches or 305 mm below the surface. There are different types of conduit available. Firstly, plastic conduit, which includes PVC or ABS, is commonly used for electrical applications because of its flexibility, ease of installation, and resistance to corrosion. Secondly, metal conduit, which can be steel or aluminum, provides better protection against physical damage and electromagnetic interference, but it is more expensive and more difficult to work with. Ground fault circuit interrupters require a proper ground connection to function correctly. The ground wire must be connected to a grounding rod or a grounding electrode system. If the grounding is not adequate, the ground fault circuit interrupter may not trip under fault conditions, posing a safety hazard. There are additional considerations to keep in mind. One important factor is the burial depth. The conduit must be buried at a depth that prevents damage from digging or other activities. Another factor is conduit size. The conduit should be large enough to accommodate the wires without overcrowding. Any bends in the conduit should have a gradual sweep to avoid damaging the wires. Sleeves should be used where the conduit enters or exits the ground to protect the wires from damage. The wires used in the conduit must be suitable for the application. For example, THWN wire is appropriate for underground use. When selecting and installing conduit, always refer to the National Electrical Code and local codes for specific requirements. Proper planning and execution will help ensure a safe and reliable electrical installation. Let's delve deeper into each of these aspects. Firstly, concerning conduit depth, the 12-inch minimum for residential applications is generally sufficient to protect the conduit from most routine digging activities. However, in areas where there is a high likelihood of deeper excavation, such as near planting beds or areas where landscaping changes are frequent, it may be prudent to bury the conduit deeper. It's also crucial to consider the type of soil. Sandy soil might require a slightly deeper burial depth compared to clay soil, as it is more easily disturbed. Secondly, regarding conduit types, the choice between plastic and metal conduit depends largely on the specific application and environment. Plastic conduit, particularly PVC, is excellent for direct burial applications because it is resistant to corrosion from soil and moisture. It's also lightweight and easy to cut and join, making installation faster and less labor-intensive. Metal conduit, on the other hand, is often preferred in areas where there is a risk of physical damage, such as in exposed locations or areas with heavy traffic. It also provides a degree of shielding against electromagnetic interference, which can be important in sensitive electronic installations. However, metal conduit is susceptible to corrosion, especially in damp or corrosive environments, so it may require special coatings or be made from corrosion-resistant materials like aluminum. Thirdly, the grounding of ground fault circuit interrupters is critical for safety. A ground fault circuit interrupter works by detecting imbalances in the current flowing through the circuit. If there is a fault, such as current leaking to ground, the ground fault circuit interrupter trips the circuit, cutting off power and preventing electrical shock. For a ground fault circuit interrupter to function correctly, it must have a reliable ground connection. This ground connection provides a path for fault current to flow back to the source, allowing the ground fault circuit interrupter to detect the imbalance and trip the circuit. The ground wire should be connected to a grounding electrode system, which typically consists of a grounding rod driven into the earth or a connection to the metal water pipe in the building. It's also important to ensure that all metallic enclosures and equipment are properly bonded to the grounding system. This means connecting them to the ground wire to provide a low impedance path for fault current. Now let's consider the additional considerations in more detail. Firstly, burial depth is not just about protecting the conduit from physical damage. It also helps to protect the wires inside the conduit from temperature fluctuations and moisture. In areas with extreme temperature variations, burying the conduit deeper can help to stabilize the temperature of the wires, reducing the risk of insulation damage. In wet environments, a deeper burial depth can also help to keep the wires drier. Secondly, conduit size is important for several reasons. Overcrowding wires in a conduit can make it difficult to pull the wires, increase the risk of insulation damage, and reduce the heat dissipation capacity of the wires. The National Electrical Code specifies the maximum number of wires that can be installed in a conduit of a given size based on the wire size and type. It's important to consult the National Electrical Code tables to ensure that the conduit is adequately sized for the intended application. Thirdly, sweeps or bends in the conduit should be gradual to avoid damaging the wires. Sharp bends can pinch or cut the insulation, creating a potential safety hazard. The National Electrical Code specifies the minimum bending radius for different types of conduit. It's important to use the correct bending tools and techniques to ensure that the bends are smooth and gradual. Finally, sleeves are used to protect the wires where the conduit enters or exits the ground. Sleeves are typically made of plastic or metal and are installed over the end of the conduit. They provide a smooth, rounded surface that prevents the wires from being damaged by sharp edges or rough surfaces. Sleeves also help to prevent moisture and debris from entering the conduit. When selecting wires for use in conduit, it's important to choose wires that are suitable for the intended application. For underground use, THWN wire is a common choice because it is moisture resistant. Other types of wire may be required for specific applications, such as high temperature or corrosive environments. Always consult the National Electrical Code and local codes for specific requirements. In summary, installing conduit correctly involves careful planning, proper material selection, and adherence to the National Electrical Code and local codes. By following these guidelines, it's possible to create a safe and reliable electrical installation that will provide years of trouble-free service. Let's expand on the discussion of conduit types and their specific applications. Firstly, regarding plastic conduit, PVC is the most common type due to its versatility and cost-effectiveness. It is suitable for a wide range of applications, including underground burial, direct burial, and above-ground installations. PVC conduit is available in various sizes and thicknesses, allowing it to be used for both residential and commercial applications. It is also easy to cut and join, using PVC cement, which creates a watertight seal. Another type of plastic conduit is ABS, which is similar to PVC but has a higher impact resistance. ABS conduit is often used in areas where there is a risk of physical damage, such as in industrial settings. Secondly, concerning metal conduit, there are several different types available. Rigid metal conduit, or RMC, is the heaviest and most durable type of metal conduit. It is typically made of steel or aluminum and is used in applications where maximum protection is required, such as in hazardous locations or areas with heavy traffic. Intermediate metal conduit, or IMC, is lighter and less expensive than RMC but still provides good protection against physical damage. It is often used in commercial and industrial applications. Electrical metallic tubing, or IMT, is the lightest and least expensive type of metal conduit. It is typically made of steel or aluminum and is used in dry, indoor locations where physical protection is not a major concern. Flexible metal conduit, or FMC, is a type of metal conduit that can be bent easily. It is used in applications where flexibility is required, such as connecting to motors or other equipment that may vibrate. Liquid-type flexible metal conduit, or LFMC, is a type of flexible metal conduit that is covered with a plastic coating. It is used in wet locations or where protection against liquids is required. When selecting a conduit type, it's important to consider the environment, the potential for physical damage, and the electrical requirements of the installation. It's also important to choose a conduit type that is approved for the intended use by the National Electrical Code and local codes. Now let's delve further into the topic of ground fault circuit interrupter grounding. A ground fault circuit interrupter is designed to protect people from electrical shock by detecting small imbalances in the current flowing through a circuit. These imbalances can occur when current leaks to ground, such as when someone touches a live wire. When a ground fault circuit interrupter detects a ground fault, it quickly trips the circuit, cutting off power and preventing electrical shock. For a ground fault circuit interrupter to function correctly, it must have a reliable ground connection. This ground connection provides a path for fault current to flow back to the source, allowing the ground fault circuit interrupter to detect the imbalance and trip the circuit. The ground wire should be connected to a grounding electrode system, which typically consists of a grounding rod driven into the earth or a connection to the metal water pipe in the building. It's also important to ensure that all metallic enclosures and equipment are properly bonded to the grounding system. This means connecting them to the ground wire to provide a low impedance path for fault current. In some cases, it may be necessary to install a separate grounding electrode system specifically for the ground fault circuit interrupter. This is often required in areas where the existing grounding system is not adequate, such as in older homes or in areas with poor soil conductivity. When installing a ground fault circuit interrupter, it's important to follow the manufacturer's instructions carefully and to test the ground fault circuit interrupter regularly to ensure that it is functioning correctly. It's also important to be aware of the limitations of ground fault circuit interrupters. A ground fault circuit interrupter is designed to protect people from electrical shock, but it is not a substitute for proper wiring and grounding practices. It's also important to remember that a ground fault circuit interrupter will only protect the circuit that it is installed on. In addition to the considerations already discussed, there are a few other factors to keep in mind when installing conduit. Firstly, it's important to use the correct fittings and connectors. The fittings and connectors should be compatible with the type of conduit being used and should be properly installed to ensure a watertight and secure connection. Secondly, it's important to support the conduit properly. The conduit should be supported at regular intervals to prevent it from sagging or becoming damaged. The National Electrical Code specifies the maximum spacing between supports for different types of conduits. Thirdly, it's important to protect the conduit from physical damage. The conduit should be installed in a location where it is not likely to be struck by vehicles or other objects. If the conduit is exposed to physical damage, it should be protected with a guard or barrier. Finally, it's important to inspect the conduit regularly for damage. Any damaged conduit should be repaired or replaced immediately. By following these guidelines, you can ensure that your conduit installation is safe, reliable, and compliant with the National Electrical Code and local codes.